Hello friends, today we are starting second derivative. In vector calculus, second derivative is very important and important for competitive exam also. So please friend, watch this video till end. Let's begin. Here we will first memorize gradient, divergence and curl. In gradient, the gradient of scalar quantity, we get vector quantity. In divergence, we take divergence of vector quantity, we will get scalar quantity. In curl, we take curl of vector quantity, we will get a vector quantity. So basically, the divergence, gradient and curl are the first derivative. So we can construct the second derivative by applying the del operator to gradient, divergence and curl. So first is divergence of gradient, del dot del into t. So here we get del dot del t is equal to del by del x plus del by del y plus del by del z dot del t by del x plus del t by del y plus del t by del z. So finally we get del square t by del x square plus del square t by del y square plus del square t by del z square, where x dot x is equal to y dot y is equal to z dot z is equal to 1. So finally we get del dot del t is equal to del square t. Here del square t is equal to Laplacian of t. So here Laplacian of the scalar function t is the scalar function. We take Laplacian of the vector quantity also. So we have del square v is equal to del square vx into x plus del square vy y plus del square vz z. Each component we have a Laplace term. Second, the curl of gradient is always 0. In expression form, del cross del t is equal to 0. So we take an example, t is equal to x square plus 2xy plus 3z plus 4. First we take del t. Del t is equal to del by del x plus del by del y plus del by del z. In bracket x square plus 2xy plus 3z plus 4. So here equal to del by del x in bracket only x component x square plus 2xy x plus del by del y component 2xy y plus del by del z z component 3z plus 4z. So we get 2x plus 2y x plus 2x y plus 3z. Okay. So let's take a curl. So del cross del t is equal to x y z del by del x del by del y del by del z 2x plus 2y 2x and 3. So we get x in bracket del 3 by del y minus del 2x by del z minus y del 3 by del x minus del 2x plus y 2y divided by del z plus z del 2x by del x minus del in bracket 2x plus 2y divided by del y. So finally we get x 0 minus 0 minus y 0 minus 0 plus z 2 minus 2. So finally we get curl of gradient is 0. Now the third one is gradient of divergence. Del in bracket del dot v. Remember del dot v does not equal to del square v minus del dot del into v. Our fourth one, divergence of curl is always 0. In expression form, del dot del cross v is equal to 0. So we have a vector field v is equal to x into x, y into y, z into z. So first we take a curl. In determinant form x, y, z, del by del x, del by del y, del by del z, x, y, z. So here we get a 0 answer. Means del cross v is equal to 0. So finally divergence of del cross v obviously 0. Our fifth quantity, curl of curl, del cross v. So here del dot v minus del square v. Remember del dot v is the gradient of divergence and last term del square v is the Laplace of vector function. Let's take an example from GATE 2005. We have vector field f is equal to x I caret plus 2y j caret plus 3z k caret. Then find del cross f. So our fifth quantity del cross f is equal to del dot f minus del square f. So first we have to find del dot f. So here del dot f is equal to del by del s I caret plus del by del y j caret plus del by del z k caret dot x I caret plus 2y j caret plus 3z k caret. So we simplify, we get 1 plus 2 plus 3. So del dot f is equal to 6. So then we take gradient of divergence. So we get gradient of 6 is equal to 0. 6 is a constant number. So derivative is 0. So last term is Laplace of f. So del square f is equal to del square f I caret plus del square f j caret plus del square f k caret. Obviously 0. First derivative is 1, 2, 3. So second derivative is always 0. So finally we get del cross f is equal to 0. So our A option is correct. So friends, if you like this video, please subscribe. Thank you.